Good evening, everyone. Welcome to the Carolina Weather Group. This is the Wednesday, August 14th, 2019 edition of our little weather get-together. We're happy to have you. This is show number 288, and we are on with Greg Carbin tonight. Greg is our guest. He works at the Weather Prediction Center, and if you're in the weather community, I'm sure you've heard Greg's name float out there several times with his work with the SPC and now the Weather Prediction Center. So we're happy to have Greg on with us tonight. This is a live broadcast. You can probably hear my dog barking right now in the background, but we'd love for you to interact with us. You can do that many different ways. We are live streaming right now on Facebook Live, Periscope, YouTube, Twitch, and all those other streaming devices. So we welcome your questions and comments. If you're listening on the podcast version, we'd love for you to chime in as well. We will let Greg kind of give out some information towards the end of the show. So if you have any questions directed towards him, you can get that information there. If you have any general weather questions about the Carolinas, we're anywhere, just tweet us as well, Carolina WX Group, and we'll be sure to get those answers. So we're happy to have you all tonight. We are starting a little bit late. We do want to say we had some severe weather roll through the area. We are going to talk about that towards the end of the program tonight. And it's been a really crazy weather week in the Carolinas with some severe weather. So with that, I do want to bring in our guest, Mr. Greg Carbin. Greg, welcome to the Carolina Weather Group. We're happy to have you tonight.
Well, thanks, Scotty. My pleasure. It's good to be here. I've heard about the Carolina Weather Group for a couple of years now, so thanks for having me.
Well, we hope it's all been good things. We hope it's been good, but it's a pleasure having you tonight. And Greg, first-time guest, so we always kind of pose this question to everyone who's joining us for the first time. How did you catch the weather bug that we've all caught here in the Weather Enterprise?
Well, as you can tell so I've been around a while, but it really starts for me with the 50th anniversary we celebrated this summer in the space program. So growing up in that era of science and space exploration got me keenly interested in science in general. So from a very early age, I kind of gravitated toward scientific subjects and realized as I grew that weather was one of those, right? I didn't know immediately that weather was really one of those. I was interested in space exploration and chemistry and biology and other forms of science. And I had a good friend of the family that basically showed me that he was doing weather observations. This was up in New England. I grew up in Vermont, and he was doing temperature observations and snowfall. And once I realized, this is very much like a scientific pursuit, became interested in meteorology. And it was really the snow that got me interested in weather and the aspect of predictability with respect to heavy snow in New England in the 70s and late 70s was sort of, that 1 out of 3 forecast big events would happen, maybe, if you were lucky. But the one that really just solidified my interest was the blizzard of February 1978, which just pummeled northern New England and even down into Boston. They're the famous pictures of Route 128 around Boston, just basically paralyzed with 2 feet of snow. We had about 2.5 feet in Vermont, and that brought the snow on the ground almost up to 6 feet. And from that point on, it was like, yeah, I'm going to do this. I'm going to try to predict this stuff, and decided to get my undergraduate degree in meteorology at Lyndon State College, which is in Vermont. And that was convenient to have a state school with state tuition that I could get a degree in, and knew I wanted to go into operational meteorology. And that's pretty much where I've ended up. So really lucky to be able to pursue my dream of studying weather and experiencing weather and working with some of the best in the business.
Well, Greg, I'm not sure that we've ever had 6 feet of snow on the ground here in the Carolinas. I know we've been close 4 or 5 feet up in the mountains. But so nowadays that you're in NOAA and working with the SPC and WPC, can you kind of highlight all of the different roles that you've held with NOAA over the years?
Sure. So I didn't get into the National Weather Service right out of school. I would have liked to have done that, but at the time there weren't a lot of openings when I was eligible to put in, and so I ended up actually taking my first job in meteorology with a company called Fleet Weather, which I think is still in business. They do broadcasting consulting work out of Southeast New York, and I do attribute some of my success in the weather service to that early experience in the private sector. Kind of learning the ropes in terms of customer service and also work ethic, and it only lasted a few years, but it was really very important experience early on. Then I actually ended up going back up to Vermont and working in the private sector as a contractor to the FAA, doing surface observations just before the age of automated surface observations. So I think that's a lost art, the art of coding up a weather observation. At the time, it was surface aviation observations. Now we know them as METAR. But that wasn't really forecasting, right? That's kind of like going out, looking at the sky, and coming up with the code for cloud cover and precipitation. But it was still very interesting. And then finally, the Weather Service was hiring, and I always knew that I wanted to work in operational meteorology, and I wanted to work for the Weather Service. So took a job with the National Weather Service in Charlotte at the Weather Service Forecast office. And that was really the dream come true. I mean, that office, that was the best. That office had everything I needed to get started. The WSR 74C radar, always been interested in electronics and radio. I'm an extra class ham radio operator. And so not only do I come down to Charlotte from New England, and I'm driving the Billy Graham Parkway every day, but the amount of thunderstorm activity is, multiple times what I've seen in New England. And so it was just wonderful having the afternoon just be like clockwork, with those storms would go up over the foothills of the Appalachians and drift east and then die just before they get to you usually. But to be able to operate the radar there, and learn about storm structure and the concepts of radar operations, and then NOAA weather radio and work in Skywarn programs. I mean, it was like, I was in a great happy place, and I was offered a transfer to Wilmington, which was another great opportunity because that was a network radar, 1957 era, big tube console radar. But the interesting thing was, at the same time, the WSR 88Ds were coming in, and Wilmington was basically what they called a spin-up office at the time, and they had the new WSR 88D Doppler radar down on Charlotte, right on Cape Fear, right on there. And I saw more interesting weather on that radar over the Gulf Stream and near the coast, and because of the topography, than I think I've seen just about everywhere else. It took many years of living in the plains to see weather as interesting as what I saw in Wilmington in just a couple of years. And also the ability to go from an analog radar, the network 1957 era radar, and then just go to the next room and look at that same storm with the 88D was a really, I mean, there will not be another time like that, right? Where you can look at something from analog to digital. So that was another wonderful experience. The boss of the office essentially was a lead forecaster at CELS in Kansas City. And when I saw an opening in Norman at the Storm Prediction Center, I asked him about it. And he said, well, if you really want to go to Norman, he was happier in North Carolina than he would have been in Norman. He said, I'll help you, I'll help you get there. You've done a lot for the office here, so I can vouch for you. And I got a job at the Storm Prediction Center, kind of an entry-level job in Norman, as they were transferring all the responsibilities from the federal office building in downtown Kansas City to co-locate with the National Severe Storms Laboratory and the University of Oklahoma in Norman. And I spent 20 years in Norman in various capacities, basically starting as an entry forecaster, moving my way up landing the warning coordination meteorologist job there at the Storm Prediction Center, which I still say is the coolest. I'll say one of the coolest, because now WPC has a WCM. So one of the coolest jobs you can have in the National Weather Service is the warning coordination meteorologist job for the Storm Prediction Center. And did that for it was about 6 years, and then decided it was time to come back east, be a little closer to aging parents. So the move to the east was somewhat strategic, but also continuing the interest in operational meteorology by coming to work at the Weather Prediction Center. So 25 years with NOAA, and about another 10 or so in the private sector after getting out of school. And looking back, it's been great, and it continues to be very exciting and very challenging.
Perfect. So let's go for a two-part question here. What does the Weather Prediction Center do, and what exactly is your role in the WPC now?
So the Weather Prediction Center is one of, I lost track here, but it's one of the national centers for environmental prediction. I'll list off the other ones. So you've got the Space Weather Prediction Center, which is located in Boulder, Colorado, kind of probably not known as necessarily a sister center to, say, the National Hurricane Center or the Storm Prediction Center. Those are the two others. There's the Aviation Weather Center in Kansas City. And then all the other centers are essentially located here in College Park. So that includes the Weather Prediction Center, the Ocean Prediction Center, the Environmental Modeling Center, and then the NCEP Central Operations, kind of the IT structure for all the other national centers. So we are essentially a national center of expertise focused on precipitation, quantitative precipitation forecasting, or QPF, if you're a meteorologist. Specializing in that, not only in the form of liquid, but also in the form of frozen precipitation in the form of snow and ice. Also, a long-time center specializing in medium range forecasting, basically looking out 7 days and trying to decipher, what both the guidance and the large-scale pattern support for the forecast the upcoming week. So a center devoted to that. And then we do the prog charts and surface fronts. We do surface analysis. I actually worked the surface analysis desk on Sunday, which is one of everyone's favorite positions as a meteorologist. You're doing real analysis. You're trying to figure out, well, is that a front? What is that front? Is that a warm front, an occluded front? Where's the low? Where's the high? And we do that analysis over North America every 3 hours. So we're responsible for the official record of the surface analysis over North America, over the continent. And then we combine that analysis with the Ocean Prediction Center, and the Hurricane Center does their analysis over the Caribbean region. That's combined for what's called the Unified Surface Analysis. So the Weather Prediction Center essentially does what's in its name, which is weather, day in and day out, specializing in where we don't do necessarily the hazard forecasting in terms of extreme rainfall. We're compiling that information from other centers. So we're looking at all the hazards from drought to flooding to severe to fire, and combining that on a national picture for a common operating picture and a common message with respect to hazards out to 7 days. It's a lot of work. If I'm fully staffed, so I'm essentially the meteorologist in charge for the forecast operations branch, with about 34 meteorologists that I supervise, which is a lot. And they're all great. They're fantastic, dedicated public servants. And, we're working 24/7 shift work, and they're doing a remarkable job and focused on weather. I mean, just like the Storm Prediction Center, these national centers really attract some of the best and the brightest in meteorology. And once they get on board, a lot of them stay. We have many forecasters who have spent most, if not their entire career, at WPC.
And Greg, you mentioned QPF, so quantitative precipitation forecast. A lot of what goes into that tells us how much rainfall is going to occur in certain areas. And this is extremely helpful in many events that we've seen over the last several years and even before that. I wanted to get into your excessive rainfall risk categories that you issue, and what exactly defines excessive rainfall, and then how do you define the categories that go with it?
So the excessive rainfall outlook that you mentioned, Shay, is an outlook product similar to the Storm Prediction Center's severe thunderstorm outlook, or what they call the severe weather outlook product. It generally covers a 24-hour period for the next day, and then the day after, tomorrow, and then the day after that. And what we're attempting to convey in that particular product is our confidence, essentially, in where rainfall will exceed flash flood guidance or flash flood threshold. So where we expect rainfall to occur with such intensity, and where the antecedent conditions support rapid runoff, what we call rapid onset flooding. Now, I thought coming here to this, I've been to the Weather Prediction Center, I've been here now a little over 3 years, and I thought coming from tornadoes to flash flooding was going to be, this is going to be great. I've done tornadoes, I should be able to handle flash flooding. It is nowhere, it's a different animal, right? It's just a different atmospheric challenge, and it's very much unlike tornadoes, but then it has similarities as well. In other words, the conditions under which you can experience a flash flood can come about rather rapidly, similar to a tornado. But unlike a tornado, you need these antecedent conditions. You need an environment, either it's saturated soil, or it's a metro area, or some antecedent condition to exist in order for that heavy rainfall to be realized in terms of a flood. Unlike tornadoes, which you don't really need necessarily any antecedent conditions. If you got the atmospheric conditions right, you could probably get a tornado in just about any underlying antecedent, any kind of soil moisture, or doesn't matter. Tornado doesn't care, right? But a flash flood does need certain things to be in place. So what we're trying to do is convey that confidence of a flash flood event. We do it very similar to the Storm Prediction Center's approach, in that because there's so much uncertainty in these events, you have to approach them using probability. And so we have to basically smear out the influence of a particular flash flood to more than just the point at which it occurs. Because if you were predicting for the points, you would have very low confidence. But if you're predicting for an area, you can have a little bit more confidence to say, this is the general area in which I think we will see a scattering of flash flood events, or numerous flash flood events, or a widespread catastrophic flash flood event. And those words essentially correspond to the different confidence levels, or the probability, or the coverage of the events themselves. So the slight risk is relatively low probabilities, under 20%, a moderate risk, 20 to 50, and then a high risk over 50% probability that if you're in that high risk, you're going to round even or better than even odds of experiencing a flash flood within 25 miles of your location. And again, the forecasters are looking at QPF, quantitative precipitation forecasts. They're looking at antecedent soil moisture conditions. They're evaluating the vulnerability, perhaps, of the underlying demographics, whether you're in a metro area or a particular basin that tends to flash flood. Mud or debris flow potential, with respect to burn scars. Those all play a role when combined with precipitation in assessing the possibility of the risk of flash flooding.
Very good. Yeah, you answered. I had a couple more follow-ups I was going to go, but you got right to it. You're talking about burn scars and debris flows and those things. So you're pretty well in tune with the land as it is in these regions. So that's fantastic. Flipping to our next topic, I wanted to go ahead and bring that. If anybody else had anything they want to ask about the excessive rainfall risk categories, anybody from the panel? Okay. Winter weather products. Let's talk shop about that. Go ahead and just kind of explain what WPC does, what they offer for these products for folks that as we start heading into the fall.
Sure. So I should back up a little bit here and talk about, we were talking about the different centers for environmental prediction, and the purpose of these centers essentially within NOAA is that you bring together the meteorologists and you task them with focusing on particularly challenging forecast problems, whether that's precipitation, winter weather, flash flooding, or tornadoes, right? So we see that, or hurricanes for that matter. So we see the national centers are kind of focused on these particularly, challenging forecast issues that we have. And the reason that you can gain experience in those areas is because you're tasked with that day in and day out over a really large area, right? The United States. And so you're not confined necessarily like the forecast office is perhaps to just that area of responsibility, half a state or, a couple dozen counties, which is a significant responsibility when you get down to warning mode and supercell thunderstorms. But with respect to understanding the ingredients necessary for severe storms or flooding, you can apply the concepts of forecast meteorology across a relatively large domain. And if you're tasked with that day in and day out over a large domain, you gain a level of experience perhaps that's greater, say, than someone that may not experience that kind of forecast challenge as often when they're focused on a smaller region. So these centers of expertise are important in terms of providing an overview, a big picture, but also insight and knowledge that may not be available elsewhere, and focusing that knowledge into products like the excessive rainfall outlook, mesoscale precipitation discussions, and winter weather. So with winter weather, the focus is again on the synoptic scale, the pattern recognition for winter storms, and applying some of the latest guidance with respect to ensemble techniques in developing probabilistic approaches to snowfall. And so we're working actually this coming winter on an experimental, what we call the winter storm outlook. Just like other outlooks, is going to look, day 1, 2, and 3, various periods of time. And the forecast will be the probability that you will meet winter storm warning criteria at your location. So the idea behind this product is that it can, similar to the convective outlook and the excessive rainfall outlook, these should provide insight and some level of guidance and consistency to the rest of the Weather Service with respect to issuing watches, whether that be a winter storm watch or a flash flood watch or a tornado watch or a hurricane watch. So the outlook provides kind of the first glimpse at confidence with regard to these hazards. And so we're working on this winter storm outlook for this coming winter. And it's basically going to be threshold based because that's the way the Weather Service currently operates with respect to winter weather. Not entirely sure, but in the Piedmont of North Carolina, winter storm warning threshold might be something, I'm guessing maybe 4 or 5 inches in 12 hours would be a winter storm warning. I'd have to look at the map. Is it 4? Yeah.
I think it's 4. Yeah.
Yeah. So 4 inches of snow in 12 hours. What in 3 days from now, what's the probability of that occurring with a particular system? And we'll have essentially a 30, I think we're going 10, 30, and 50% probability. And at the 30% probability, you probably want to start thinking about issuing a watch. And certainly if you get up around 50 or 60, you might even go into warning mode for a winter storm, even if you're 2 days out. So we're going to test this coming winter. And we have what we call the Winter Weather Desk. But we also have a development branch where we've got research meteorologists working on ensemble techniques and snow liquid ratios, and combining the QPF that's generated at WPC to come up with snowfall and ice forecasts for these winter storms. Really challenging. And of course, the real challenge, I think, is the collaboration that needs to occur between our center and the Greenville-Spartanburg office or the Raleigh office with respect to getting on the same page with respect to snowfall amounts, high-end amounts, low-end amounts, confidence, and whether we issue watches and warnings. That's up to the local office when it comes to winter weather. And we want to collaborate and provide those offices and the rest of the weather enterprise with the best information we can from the experts that are looking at it at the Weather Prediction Center.
Very good. Scotty, I think we had Blacksburg, Virginia on when they were testing out their new product. Have you worked with them on that at all, Greg?
What's their new product?
Scotty, do you remember what they were doing at Blacksburg? They were coming out with a new storm warning.
Yeah, they had they were one of the test beds for the new enhanced hazardous weather outlook programs that has been I think now installed. I think all of the East Coast may be participating now with those products. So I, for one, really excited to hear about that. I didn't know the winter storm outlook was coming down the pipeline, but I think that's a great tool, especially, Greg, you forecasted here in the Carolinas before. Winter weather's tough here in the Carolinas, so that's a great tool to for us forecasters to be able to grab a hold of and know that there's some confidence that we could see something coming down in the next few days.
So, and beyond that, not very far out is another application we're trying, which is what we're calling the Winter Storm Severity Index, which essentially is very much like other outlook categories: slight, moderate, high impact from winter weather. So it takes into account actually population, it takes into account snow load, wind, temperature, and we're trying to apply ensemble techniques to this winter storm severity index, and eventually combine the winter storm outlook with the winter storm severity index. So we can say, here's the probability that you will reach or exceed moderate risk category for winter storm impact. So not so much talking about snowfall amount there, although that plays some role in it, but what can we say about the impact that this event will have? Will it be long lasting? Will people be out of power for days, or will it be relatively easy to recover from? So this impact scale is where the Weather Service is going in this direction of trying to provide information regarding societal impacts in terms of weather. It is very challenging, but we're using this winter storm severity index as a test going forward.
Yeah, Greg, I want to jump in real quick and switch gears from the winter side of things. You guys make a really cool product, on the day 3 to 7 outlooks that you guys put out. And you were talking earlier about, synoptic pattern recognition and using ensemble techniques to really try to get a handle of what the weather's going to be outside of 5 days. Can you talk a little bit about what goes into that 3 to 7 day product that you guys put out?
Yeah, thanks, Chris. That one is relatively new to WPC. We transitioned what we're calling the Hazards Outlook, which was already the Hazards Outlook, but it was being issued by the Climate Prediction Center. I think I missed them in my roundup earlier. So there's another one. They're just downstairs, and they're important. They do some great stuff with the extended range, all the way out over the next year, essentially, which. Yeah, we can argue about it, the quality of the forecast, but they're doing it in a scientifically robust approach. It's just not easy to predict that far out as far as the large scale temperature and precipitation patterns. But they started this day 3 through 7 hazards as sort of a compilation, really. I don't think they weren't really applying short-term forecast or medium-range forecast techniques. They were really compiling information from other centers. And because WPC has that role in the medium range, we felt that there was a better home for it at WPC than at the Climate Prediction Center. So we transitioned that over. There are aspects of that Hazards Outlook that we basically just repackage, and including drought, severe weather from SPC, I think the fire weather, the river flooding, those are just repackaged on that map. We take what already exists from the centers of expertise and we just plot it. However, temperatures, precipitation, winter weather, potential for flooding, those are categories that we inherited from the Climate Prediction Center, but where we specialize in forecasting in the medium range. And so percentile rank information, I don't know if you go to the WPC page and you use forecast tools, you can go to, I think it's called the situational awareness display. Basically, it's looking at long-term deviations from model climatology using the latest forecasts from the global forecast systems or the North American forecast system. So take the ensemble, take the mean of the ensemble. How does that differ from long-term climatology when you go out in time? And give you some idea of whether you're dealing with something that's potentially extreme, or an outlier event that we need to pay attention to. So that's one method you can use for that. Teleconnections, another long time tool that's used, when the patterns start to set up in a certain way in one part of the globe, how does that affect downstream weather in other parts of the globe? The climate forecast system model, I did a little bit of work with that before leaving SPC in terms of attempting to do a longer range forecast for severe weather. It shows some skill, but that drops off pretty significantly after about 7 days. And so we're in that zone from 5 to 7 days where if we're dealing with something significant, it probably is going to show up, and we should probably get the message out that we're dealing with something different here that could have quite an impact. So we used to call that in severe weather, and you call it in other hazard forecasting, synoptically significant events or synoptically evident events. They should show up in the numerical model guidance. May not be all in agreement as far as how that evolves, but there's a signal for something big coming in the days ahead, and that's what that product is designed to convey.
Yeah, it's a great product, and just looking at the verification over just 7 day temperatures over the past 10 years, and there's been almost 3 to 4 degree improvement across the board in verification. So whatever you guys are doing, you're doing the right things, and just hopefully technology will enable everybody to just get even better with it.
Yeah, it's pretty remarkable when you look where we've come from in the last couple of decades, and I think a lot of that is due to the use of ensembles and probability forecasting to the challenge. When I started out in meteorology, there were two basically. There was a spectral model, and there was the limited fine mesh model. And you didn't really have much information to give you insight into atmospheric predictability. But now with ensemble modeling, you can say something about the predictability of the regime you're in. And sometimes you just have to say, this does not look like a scenario that we can be all that confident in. You've got a lot of different solutions in the next, say, 5 to 7 days. But other regimes are very predictable. Large scale regimes that set up like essentially the heat dome over the central part of the country right now, or even the transition of that large high amplitude ridge to more of a zonal pattern that we're seeing this week. That was pretty evident about a week ago in a lot of the numerical model guidance. So ensemble forecasting has really proven its value in terms of improving the accuracy of forecasts out several days.
Yeah, I wish most folks that really understood what goes into the ensemble forecast. The Euro puts out a 51-member ensemble, and the GFS about half that. That's 70 possible solutions, but being able to recognize a pattern out of all of that and then put it to paper, it's pretty awesome.
The winter weather forecast ensemble that WPC uses for the short range is, I think it's close to 50 members at this point.
Greg, switching gears a little bit, we're talking about the excessive rainfall outlook that you guys produce. Over the past, 3, 4, maybe 5 years now, we've really seen an uptick in tropical activity and an uptick in just heavy rain events in general. Talk to us a little bit about getting prepared for tropical events. We see Ken Graham down at the Hurricane Center. They do a lot of Facebook Lives and getting information out. I even seen you guys doing a lot of updates on the heavy rain possibilities with landfall and hurricanes. So talk to us about maybe what's going on right now in your office as we get it ready to head into the peak of hurricane season. How do you guys go about approaching landfalling tropical systems and things like that?
With a lot of trepidation. So one of WPC's responsibilities is to provide operational backup for the National Hurricane Center in the event that they go down. I'm not sure how well known that is, but that is one of our responsibilities. And so we have a really close working relationship with Miami and the forecasters there. I was on the phone this afternoon with some of them. We have about a 100-page plan in terms of what products we will supply in the event that hopefully they won't go down. Although we tested some of this a couple of years ago with Irma. If you remember correctly, I think about 5 days out, Irma was a bullseye to Miami at about maybe a Category 4, and it was looking like we would have to back up the National Hurricane Center if they went, if they went down. That was a distinct possibility. So we actually moved a team up to College Park, and we actually took over some of the tropical cyclone advisories for the storms that were out in the Atlantic at the time. So there's that, but there's also, as you mentioned, the heavy rain threat. And I think Ken at the Hurricane Center and his staff are doing a great job in understanding, not only, the challenges of intensifying tropical cyclones, as we saw with Michael last year, but the track forecasts have improved dramatically. And then again, we get back to impacts. Okay, so you can get the track right, and you can get the intensity right, and you can warn for surge and wind. But the inland rainfall threat is a significant threat to life and property when a system moves in, as we saw with Irene, we saw with Sandy, Florence, Harvey. All these storms, devastating impact from rainfall. And so that is well recognized now, not only by the WPC, but by the National Hurricane Center and all meteorologists involved in public safety, that we need to message the rainfall risk. And it does appear as if, just in recent memory here, we have seen just unbelievable amounts of rainfall over just a very short period of time. And Florence in the Carolinas was a remarkable example of that. What strikes me about these events is that again, because they're so significant, they're usually well handled by numerical model guidance because there's such a large perturbation on the atmosphere. You certainly hope the physics and the numerical models can handle that. But it was really fascinating to watch. The models generate precipitation amounts that were just astronomical. 65 inches of rain in a couple of days, and you're thinking, how can that be, right? It just doesn't seem possible because we haven't experienced it before. And then this realization that actually could happen, right? Especially in the case of Harvey, trying to message that and be firm and committed to a message 2 or 3 days out to something that you've never experienced before is incredibly difficult to do. And when you want to go back to tornado events, a very similar feeling came across all forecasters I worked with respect to the April 27th, 2011 tornado outbreak. We knew it was going to be bad, but none of us had ever experienced anything that bad. So it wasn't within our frame of reference to say 300 tornadoes or 300 deaths and hundreds of tornadoes. Maybe, we knew it was bad, but not that bad. And the same with these flooding events. You know that they're potentially catastrophic, but you may also be dealing with something that you don't have a reference to historically. And that puts you in an area that's really challenging with respect to messaging. So coordinated messaging is important. Being on the same page from the local office and the local emergency manager all the way up to the National Hurricane Center is incredibly important. And the reason it is because of a thing called confirmation bias. If I'm sitting in Eastern North Carolina and I think, I'm hearing a story about a hurricane coming in a few days that's going to drop 3 feet of rain in 2 days and just be catastrophic and I need to leave. If there's another message out there that says, don't worry about it, it shouldn't be too bad because we've lived through these before, and it comes from even a quasi-authoritative source, and you don't want to move, that's the message that you're going to believe, right? But if you can't find that message from any authoritative source, if everywhere you turn is essentially going 3 feet of rain is coming and you're going to be washed out, you need to leave. If you can't find any other alternative message to fit what you're hoping for, it's probably more likely that you're going to move. At least we hope. So coordinated messaging and key messages as well. We're working very closely with the Hurricane Center and other partners across the enterprise to come up with a set of key messages we can all agree to and we can all support, and that will be echoed, over and over again from a number of platforms.
That's some incredible stuff there. And one last question, you brought up something that really kind of perked my interest there. You said April 27, 2011, me being a tornado guy, and you talking about tornadoes also before our show. While you were at the Storms Prediction Center, what's maybe the one event that really sticks out in your head, not just from a forecaster standpoint, but also personal? Can I walk us through maybe one of the tougher days that you've had to work, and what it was like to have to walk in those shoes and make the decisions you had to make?
So you'd think it would be 2011, and that's certainly one of them. It's hard to pick one, but I'll tell you about May 3rd, 1999. That was one of the other earlier, more tornadoes. I hadn't been at the Storm Prediction Center. I think I'd been there maybe three or 4 years. So I wasn't working at the Outlook or the mesoscale desk. I think I might have been spinning up on the mesoscale or training on the mesoscale desk that day in Norman. I had a colleague there too who was with the science branch, very interested in chasing, and really bright guy. But we were struggling that day to understand how are things going to evolve. And when I look back now, it's like we didn't have storm scale, we didn't have convection allowing models, we didn't have models that looked like radar, right? They were blobs and they were pretty crude. This is 1999, and it just makes your head spin when you think how fast and how far we've come. But the storms developed quickly, and every storm is rotating. And as we've seen before, since that time, one of the storms that set up to the southwest of Oklahoma City became very intense and developed a tornado very quickly down around, if you know the area, Chickasha, Anadarko area. And that became essentially a stovepipe tornado that tracked up along the turnpike between Lawton, Oklahoma, and Oklahoma City. And I was watching, I got home from work. As I'm leaving work, my colleague who's into storm chasing says, this is going to be pretty bad. And he was very accurate in that statement. So I had small children, and I got home, and I'm sitting watching the news coverage with the helicopter, essentially the helicopter video following the stovepipe tornado up northeast as it's plodding along. And the thought that comes to mind is that, this supercell is in a perfectly pristine environment to be that extreme and that violent. And when you think about it, the atmosphere, thank goodness, doesn't put those conditions together very often or for very long, right? Because the purpose of the tornado is essentially to change that environment as quickly as it can, because it's in an incredibly unstable regime. But this particular storm was not going to change. I mean, it had already done, the right-hand turn. It had fully formed, and it was moving along, and it apparently was not encountering any environment that was hostile to it that would, cause it to weaken. And there was a moment of about a 5-minute period of time when the sirens went off in Norman, and I wasn't quite sure whether the tornado had tracked across the turnpike, which would mean it could be a problem for Norman, or whether it had remained on and just to the west of the turnpike, which means I would probably be okay in Norman, but Moore or Oklahoma City was definitely under the gun. And I realized after about 5 minutes, and I had a 5-year-old on my lap that was screaming because the tornado warning's going off. And it's like, my wife said, what do we do? I'm like, hold on, let's find out where this is. And once I realized after about 5 minutes that it was going to track to the north of us, we're going to be okay. And not long after that, my older son's like, let's go, let's chase it, And I'm like, well, that's not likely to go well. We're in the metro area, but we did get in the car and we drove to a point where we could see the storm to the north. And at that moment, I was also listening to the AM radio station out of Oklahoma City, and they had a reporter who was following the tornado in the wake, and he was in tears. He was crying as he was reporting. And the thought that came to mind is the famous audio you've probably all heard of the Hindenburg. And the Hindenburg exploded and went down. That reporter is just emotionally overcome by the destruction he's witnessing. And that's what I thought of at the time. But I also saw this supercell in front of me that was, twice the height of Mount Everest. It's over 50,000 feet. It's got this back edge to it. I couldn't see the tornado, but I could see the base. And this thing is just remarkable and incredibly destructive at the same time. And that day just stands out as a day where a lot of things sort of came together for me as a meteorologist, and the challenges we face in terms of trying to figure out, what's going to happen when faced with a tornado forecast at 8 a.m. in the morning. What if somebody asks you, well, what about my city or my house at 5 p.m. this afternoon? We still don't have the science to do that. And that day, just that's one of the ones that stands out.
I definitely can understand that. When you said May 3rd, 99, that definitely got my attention, because that one should stand out to anybody that's got a little bit of weather weenie inside of them. But 8,000 homes were destroyed in that tornado, and only 36 people lost their lives. So, you guys obviously did something really great that day. And, it could have been much, much worse, especially, looking at the population, especially up the Bailey Turnpike from Lawton all the way into Norman and OKC, Dell City, that whole area. It's just, there's a lot of people out there. We were just out there a couple of months ago.
Mm-hmm.
It should just be thankful, listen to warning.
Yep.
Greg, going back, you were talking about that event a little bit before that. Your first job, as you were talking about a little bit earlier, was at the National Weather Service office in Charlotte, North Carolina. So some folks who are listening tonight may have not realized that Charlotte did have an office. So talk to us a little bit about that. Do you remember the forecast, the counties that you covered? Kind of talk to us a little bit about your time in Charlotte and also Wilmington.
Yeah, fond memories of Charlotte. Big change, kind of a culture shock coming to the South from New England. But first job, and really excited to do well with the National Weather Service. So I think our county warning area may have extended west to Rutherford County, and then east to Union, and then maybe north, not really sure, Anson perhaps, and south. I think we had down through Rock Hill. We didn't go too far into South Carolina, but we had one or two counties down there. So a significant area for dangerous weather. And in fact, I showed up there on station just a few years after Hurricane Hugo, which was well remembered by everybody I talked to in the area, because Hugo came roaring up through there from after landfall in Charleston and did a tremendous amount of damage in the Charlotte metro area. But the real thing there was, of course, winter weather. Probably one of the more remarkable events was, a trace of freezing rain one morning. Just total devastation, cars everywhere, traffic standstill, and the airport shut down. But like I said earlier, it was being able to watch the storms develop in the afternoon off the high terrain to the west and the foothills and the Appalachian Mountains, and then drift east. I remember the remnants of tropical storm Beryl too, where every little shower was spinning like a top, and the tornado reports were flying out from Hickory all over the place. Not a lot of widespread damage, but there were a large number of tornadoes with Beryl, and we were issuing warnings by running to the NOAA weather radio at the time, and that was a lot of chaos for one evening. The office, I thought, was very well run. The official in charge, not a meteorologist, but our official in charge was Ron Kuhn. I think there are a few folks that probably remember him well. And he ran that office kind of like a military base. You had to do it right, or he was going to be on your case. And he had a funny test for the radar. He would go in to get you qualified for radar. He would go in and he'd mess up all of the buttons and all of the inputs and just mess the radar up. And you would have to go back in there and get it back online within 5 minutes to get to meet his test. And knowing radar, I mean, I was just, that's what I was living for. I mean, I knew the radar manual. I knew how the radar operated, and he did it. He's like, all right, go in there. And I went in, and, you know, maybe a minute or 2 minutes and a half, I had it back up and running. I come out, it's all set. He's like, you couldn't have done it that fast. There's no way. No, you could not. It's not working. You probably didn't pass. He goes back in, and all right, it's running. So I felt pretty good about that.
Two follow-ups. We are actually going to do a 30th anniversary Hugo show. So I want to ask you, you know, I know you wasn't here in 89, but any stories that floated around in the weather office about Hugo? And then also, I'm not as sure the exact date you joined the Charlotte office, but 1993 around here in the Carolinas was also known for the blizzard of 93, the superstorm of 93, the big snow event. Any recollection of that as well?
Okay, so I came down in May of 93 to Charlotte. So I was in Vermont for the superstorm, which was just another storm up there. It was just another snowstorm. And I got down there, I think the summer of 93, of course, was the summer of major floods across the Midwest. And I think the Piedmont was baking in a heat wave during that summer. So I just missed the blizzard, the storm of the century there in March of 93, which I know basically from Alabama to the Mid-Atlantic was a big deal. Up in New England, it was just another snowstorm. But yeah, I don't. So the heat of that summer stands out to me, and then the Palm Sunday tornado outbreak stands out. I was there for that. I worked a midnight shift, and I went home and I told my wife, if the sun comes out, we're dead. It's not going to be pretty. And the sun came out, and we were hiding in the closet later that afternoon.
In regards to Hugo, like I know 89 you weren't here, but any, this is the benchmark. The blizzard of 93 and Hugo is kind of the benchmark for the Carolinas, especially the western half. In the weather office, I mean, did any of the forecasters tell you stories of being there, or anything that kind of really sticks out about Hugo to you coming into an office that just experienced that a few years earlier?
You know, I do remember a few conversations. I do remember that there were a few folks that had lost power, and the power was out for a considerable amount of time. I remember some stories there. For me, I think what's remarkable about Hugo, and I was obsessed with it, I was watching it the whole time, was the CNN report from John Zarella in the eye in Charleston. He actually got the satellite back up, and he was doing a live report. I think it was, late night, middle of the night when the eye went over Charleston, and he was able to get a report out. If you can find that video, that to me is quite memorable. But yeah, as far as the stories go, just the widespread damage that they had there, and the length of time some people went without power. I heard some stories about that.
Well, Greg, we have certainly enjoyed having you on tonight, and I feel like I'm going to have to ask you to come back on, and we can just talk about different storms that's kind of piqued your interest. It has been a fantastic conversation, and we're very appreciative of your time tonight. If our followers want to follow you on social media or the Weather Prediction Center, what you guys are doing, how can they do that?
So the Weather Prediction Center is at NWS WPC. I'm at G, that's in George or Greg Carbin, at G Carbin on Twitter. I know we were going to cover social media, but we probably run out of time on that one. But that's where I am occasionally. Tried to back off a little bit on that because it is so time consuming. But those are the two handles for Twitter. And of course, Weather Prediction Center also has a Facebook page, and of course the web page. I would recommend the web page. There's just like SPC. I mean, there's a lot of links there that just you can keep looking at weather information until the cows come home, and I will keep talking weather until the cows come home too. So be glad to come back. You get me talking about weather, it just doesn't stop. So I'll have to have another show. But thank you very much for having me today.
Challenge accepted. We're gonna bring you back. We'll hit social media. Stick around for just a minute. We're getting ready to wrap up. I quickly want to toss it over to Shay right quick to do a quick tropical update, and then James is going to finish it out with some weather news. And Greg, we want to keep you around for after the show for just a second if you don't.
Okay.
You got a few minutes.
Sure.
All right, Shay, off to you, buddy.
All right. Thank you very much, Scotty. Yeah, we're talking tropics right now. It's been pretty quiet in the Atlantic Basin so far for the last couple of weeks or so. And a lot of it has to do with just a lot of upper shear across the Atlantic Basin. Atmospherically, not conducive for development. We had a couple tropical waves. One thought we might get a name, Chantal, but then that fizzled out before it made it to the Leeward Islands. So we have very warm sea surface temperatures, but we have a lot of dry air aloft. We have Saharan dust aloft across a wide spread across the equatorial Atlantic. So a lot of factors are just not, the ingredients are just not there yet. But we do want to caution that El Nino has now ended in the Pacific. And what that means is that the pattern for the Atlantic Basin tends to go up a little bit. The upper shear relaxes a little bit. So NOAA went up on their numbers a little bit to just above normal. And so that report went out on August the 8th when they officially ended El Nino and upped their numbers just a little bit for major hurricanes and other tropical cyclones as well. So just be aware, even though it's quiet right now, as we get towards the middle of August, that we are getting into the more active season. I'm going to go ahead and talk a little bit about El Nino. Let me know when you can see the screen. All right. And my screen did something really weird, so I'm going to have to figure out how to get back to it. But let me see here. I think I can figure it out. Either way, what you see here is the El Nino regions. And so largely what we have, this is equatorial Pacific Ocean. And Nino 3.4, this region is what's typically watched the most when the CPC is designating El Nino or La Nina conditions or even neutral conditions, which is what we're in now. So a lot of the majority of data is coming from this area right here. And if we look at the thermocline, this is the level, the depth of warm water across the equatorial Pacific. And we see right about 150 degrees west and over towards 140 is where El Nino 3.4 starts. And you see this cool water upwelling over here to the east. And so what we have is we have a very shallow layer of warm water. And that's been a fairly big trend. In fact, if we look at the CDOS Nino index, we see a sharp drop off here. And so in order to keep an El Nino active, it has to be about 0.5 degrees Celsius or higher for its anomalously warm values. And that's, and it was barely hanging on here for some time, but now they've gone ahead and said, look, the El Nino is over. It's officially done. We're in a neutral phase right now. And that's expected to go on through winter of 2019 to 2020 with about a 50 to 55% chance. Here is the red line here. You want to kind of look at this. This is the dynamic average of all of these. And so we kind of look at this line. Looks like things are going to stay below that number and we'll stay in the neutral phase. And maybe a possibility sometime down the road of getting back up towards that 0.5, but nothing significant. There's nothing really pointing out that we're gonna get back to El Nino anytime soon. If we look at the Atlantic Basin, the wide view, here is the Saharan dust, and this is basically mid-level dust that's captured across. It heads across the Atlantic Basin, across the atmosphere at about 500 millibars, or about 18,000 feet, give or take a few thousand. And this really hampers development in the tropics. It doesn't allow a lot of vorticity to sustain itself or surface flows to develop because of the dry air aloft. And even though we get some impressive tropical waves off of Africa, this dust tends to kill it off. Now, we do have a little bit of a break coming in between these plumes, call this the dusty tongue of the Sahara. And so we're watching the Caribbean right now, the Western Caribbean, maybe a little bit of activity starting to show up on some of the models to maybe push up into the Gulf of Mexico by late next week. The signal is very weak for even a tropical depression. GFS fell off, but just an area we're going to be watching. So these are the areas we need to be watching right now are the Gulf of Mexico, the Western Caribbean, even along the Carolina coast and the northern Gulf of Mexico states where some of these homegrown systems can develop. And I think that's going to wrap it up. So things are pretty quiet. I just want to give you kind of a synopsis of how the El Nino operates and what the numbers come from, and let you know that there really isn't a whole lot of activity out there, but we're looking at maybe a weak signal for next week. Let me pull up one more thing here. And just a reminder, we're only here in this portion of the season. We're getting into the more active part of the season as September 10 peaks out. But even we get into October, we still see systems coming through here. So we're starting to see an uptick as we get through the end of next week. Things may start to unfold. We may see some more activity. And I think that's going to do it. And Scotty, back to you. I'm going to try to figure out how to unshare my screen now that this thing has. I'm trying to figure it out. It's got me locked here. So
I'll take it from here, guys.
right.
Let's take a look at
I got
the
it.
storm reports that came in yesterday as a part of the severe weather that came rolling across the area. You probably noticed this no matter what portion of the state you are in. This is coming up on your screen right now. These are the storm reports just from yesterday alone. I still have on the screen all of the severe thunderstorm warnings. They're outlined in yellow. And let me paint this picture for you. If you're on our podcast, we had a severe thunderstorm warning all along the Interstate 77 I-40 corridor stretching from Hickory all the way to Raleigh, and you can see also on your screen there the numerous downed tree reports. Here in the Charlotte metro area, one of the biggest takeaways was a microburst that we saw just north of the Hickory area along Lake Hickory, where numerous trees came down, including on the home of a woman who just moments earlier had grabbed her infant son out of his sleeping crib just as a tree came crashing down onto their home. They are luckily doing just fine, but a remarkable story there of just the power of these storms. And Scotty, I understand where you are in Morganton, we saw also some of those strong winds and heavy rain coming rolling on through.
Yeah, we did, James. It was really a peak heating yesterday afternoon. Around lunchtime, you could really feel the heat and humidity, and you knew the storms were moving in, and it definitely had that feel of seeing some strong severe storms. So we were under that severe thunderstorm watch, I think it was around 1, 2 o'clock when it was issued, and the severe storm started here in the foothills around 3:30, and then moved into the Piedmont areas. We got some video that you may or may have not seen on our social media stuff. You may be able to feel it here. This is actually my backyard. This was as the storms were moving through the area. Did get an anemometer reading, but I would say at least 60 to 70 mile per hour winds. We had some trees down further up behind my pool area, so it was very quick hitting storm that lasted maybe 2 minutes. The rain had pushed out, and the sun had started to pop out about 5 minutes after that. So pretty quick hitting storm, but needless to say, with 60, 70 mile per hour wind, will do some damage. So a lot of cleanup going on here in the neighborhood. I've got to get up there and get all those leaves and sticks out of the pool that you can see there. But again, just more of a headache than anything. Thankfully, no injuries here. So all is well. Just have to start to clean up everything. Thankfully, no strong thunderstorms today in our area, but we had some down in the Charleston area.
Yeah, that's right.
Nice little rainfall storms over the next few days.
Matter of fact, Scotty, I already have pulled up on our screen here now showing a graphic for the local storm reports that were filed today, and the biggest bullseye was in that Charleston area where we had numerous trees come on down. We had severe thunderstorm warnings, meaning, of course, that we had at least 60 mile per hour winds, and you can see that purely in the tree limbs that came down across the area outside the Charleston area and back over towards Interstate 95 as well, too. We also had other warnings, a little bit more isolated and more scattered than what we saw yesterday, but you could even see at one point a local storm report coming in. This, I believe, was from the overnight hours when we had that rain coming through the Carolinas while you were sleeping, and that actually went storm warned outside of the Greenville-Spartanburg area last night. So it's been a pretty active day or two here in the Carolinas as we've just been heating up and reaching into those 90s each day. Plenty of atmospheric fuel, and this is the result of it. Scotty?
Definitely so, James. So thankfully,
90s guys, come on, man. We got over 101 the last 2 days.
yeah,
Oh,
you
you'll
know,
hear it.
Heat index or actual temperature, Chris?
Actual temperature is 101 today.
Wow. All right, so from Charlotte perspective, I'm not sure we crossed the triple digit.
And hopefully, if you did experience any storm damage, hopefully everything can get cleaned up pretty quickly for you and everything get back to normal. So we appreciate you joining us, and we'll see you back here next Wednesday night for another episode of the Carolina Weather Group. Oh, he